thank you for joining us and thank you for posting our training program. My name's Ian. I'm the owner of Pain Free Power, which is a bike fitting studio based in Stockholm. I come from a cycling background myself, having competed in time trials in the UK, and also studied physics at university and went on to do a postgraduate degree in sport and exercise biomechanics. So hopefully should be in a good position to help you guys to optimize yourselves for a faster season next year. You'll be seeing a lot more of me through these next few weeks with the weekly lectures on the training plan. And we wanted to start off with a lecture just in terms of the fundamentals of what is aerodynamics. So it's something we think is sometimes omitted from what people are aware of when they're thinking about aerodynamics and how to make themselves faster. So we wanted to start with something quite simple to just explain what is it we're trying to improve. So aerodynamics is basically just how the air interacts with an object that's moving through it. It manifests itself into four forces. Drag force is the one that we're predominantly thinking about as cyclists, but it can also create like a thrust force, so a propulsive force if you have a big enough tailwind, for example, which doesn't generally seem to happen for me, but you get a thrust from that. Likewise, it can create kind of vertical forces, so you can get a lift and a weight force. So weight forces would be something if, for example, you were looking more at like racing cars and you're trying to increase downforce into a corner, for example. That's something you can use to try and direct the airflow to create more artificial force in this weight direction rather than just the load of the mass of the vehicle. There are also lateral forces that are being applied as well with kind of crosswinds and how it's going to affect whether you sit sort of central or move across the road. But in terms of this sagittal view of the position, these are the four forces that we're interested in. So drag force, like I say, is the one that we're predominantly thinking about as cyclists. That can be kind of over 90% of the total force resisting your movement once you get to high enough velocities. So we want to kind of work out what is creating this force and how we're going to try and minimize that. So that's basically created based on this drag equation. This kind of explains all the variables that go into creating this drag force. Something that maybe some of you have seen previously, but we'll break down some of the variables and explain what we can and can't do with trying to improve the situation. So rho, this is our fluid density, which is basically just the characteristics of the area you're moving through. So that's basically like the altitude that you're at, the air temperature, the pressure of the air that you're in, basically. And that's something that isn't going to be something you can change generally. It's something that people will maybe play around with if you're doing like an hour record attempt or something, for example. So you'll pick a velodrome, which allows you to try and improve this value and get as good a smaller fluid density as possible. But for the majority of us, race day is where it is and what it is, and it's not something you're going to be able to affect. The V or U aspect of the equation is the speed of the object relative to the fluid. So that's your net speed relative to how fast the air is moving around you. So if you had a really big headwind, for example, this value is going to be greater than your velocity because it's going to be the speed of the air moving towards you added to the speed of you moving towards the air. But conversely, if you have a tailwind, it's going to be subtracted from the velocity that you're going because you're moving less relative to the fluid around you. Again, not something that you really are going to be changing particularly other than we want it to get higher. But to reduce your drag force, you would have to reduce that value. So nonsensical to try and reduce drag by reducing speed. That doesn't really help your results in the slightest. It is, though, the biggest variable in your drag force. So you can see this is a squared variable within the equation where everything else is to the single powers. So that is going to have a bigger effect than anything else, unfortunately, which is why we need to optimize the things we can. So the last two aspects are CD and A, which a lot of you have seen as CDA as a single metric, but it is two separate parts that go into this, basically. So the A part we'll talk about first just because it's a little bit easier. So A is basically just the frontal area of your position on a bike. So if you looked at you from head-on position, how much that area is hitting the air. That does vary a little bit when we're starting to think about side winds, for example, because then the movement of the wind again isn't entirely perpendicular to your movement. So it's parallel to your movement, sorry. So it's something that can be a little bit oversimplified, thinking only about it as a frontal area, but generally that's the direction of your travel. So that's what we're interested in. The CD part then is our coefficient of drag, and this is basically essentially how slippery an object is. So how well an object is going to move through the air. So there's certain shapes that will move better than others, like a flat surface, for example, is going to be much harder to move through the air than something that's kind of more of a rounded surface that's going to, it's a bad example with my hand, but where it's going to kind of roll over a surface rather than having this flat object to hit it like a wall. So on a bike, we can certainly try to improve both the slipperiness of a surface by things like improving the body shape that you have on a bike, or by changing materials, so different helmets, different skin suits, and bike aspects as well in terms of handlebars, armrests, the wheels, the tires, lots of things that can go into the CD value on a total system element. So there's kind of local CD aspects, so trying to improve all those individual parts and how they're going to affect the CDA of the system as a total. So when we're thinking about that, we've got kind of an example of one of the pro triathletes we're working with here, and this is obviously a fairly nice position. I would think we've been doing this with him for a while, and it goes quite fast. But when we're thinking about airflow, we're trying to think about where the air is going to go as it hits a cyclist. So we've got kind of leading edges in terms of the front of the wheel here, the front of the hands, and then as well potentially you can classify the front of the head. But the air is already going to be disturbed a little bit by the time it reaches this point. So what we're trying to do is to create as much of a laminar flow as possible around the body. So air can move in kind of two different kind of categories essentially. So we've got laminar flow and turbulent flow. So laminar flow is going to create a much lower coefficient of drag for us. So that's definitely something we want to try and adhere to on a bike position. So we want to try and keep the air stuck to the body for as long as possible. So in Adam's position here, the air is going to kind of flow over the torso and maybe separate somewhere around here. We'll get a sort of a flow separation starting to occur. But as much as possible, we want to fill this space behind the hips. We want to have a small wake behind the cyclist. So when we create this nice smooth shape that the air can flow across, mixed with kind of a helmet that's going to transition the air from this head position onto the top of the back, a fairly flat back position generally, good materials through the tri-suit, that's going to allow this boundary layer of air to stick to the torso as long as possible and then separate as late as possible. And that's going to mean that we're going to have as much of this area filled as possible. Because when we're creating drag on a cyclist, a lot of it is kind of a pressure drag. So where we have higher pressure in front of the position than we do behind. So if we can try to reduce the pressure differential in total between the front and the back of the system, that's what's going to allow you to move through the air more cleanly. So when we're thinking about a bike position, like I said, we want to try and ideally kind of have this kind of smooth line through the head into the shoulders. We want to try and reduce a lot of the airflow kind of coming underneath this area of the position and catching under the torso, because that's going to already create quite a lot of turbulence as the legs are moving up into this position, and the air is going to flow in and then have to bounce around the legs. So it's going to be much, much more turbulent, the flow coming off the back of the legs than off the back of the torso, for example. So there's not much we can do entirely to control it, obviously, because the legs have to move to pedal. But thinking about trying to control the air in areas that we can, or even trying to divert the air around the legs in some way, for example, is going to be a way that we can try and drastically reduce that CD portion of a bike position. And how we can do that with some setups would be things like you'll have seen potentially with some of the newer bike designs. So this is a Q cycle as well. There's other brands that are trying to kind of replicate to some extent some of the things that Q started with, this wider fork idea, which allows the air to flow through the legs. So we're trying to think about where the airflow is going to go. So on this bike, for example, we see this nice open channels through from the fork, through the stays, and out through the back of the position, which if we think back to the previous image, is then going to fill that space behind the cyclist as best as possible, reduce the wake, reduce the turbulence, and allow you to move through the air better, which in turn is a better CD aspect of your CDA. As well, things like, for example, with the spaces up through here, for example, we can also see how that's going to direct the airflow between the legs. So then we're not as concerned about the legs creating turbulent flow, because we can try to direct the air around that. We can do similar things with kind of angle to like a fork or something, for example, where it's going to try and divert the airflow around the legs in this direction. And with the spacer arrangements, trying to point things inwards, for example, again, to try and control where the air goes, because we need the air to flow somewhere. So creating like a flat object in front of a bike isn't a great solution often, because it's going to create, like we spoke about, this kind of wall where you're going to ride into. So it maybe then doesn't hit you, but it's going to already be ineffective. So we need to allow the air to flow somewhere, but we want to try and control where that air is going to go. So what we're going to be working on with this course is a lot of the things around how you can improve a lot of the body positioning aspects of you. We'll discuss later on as well some components and bikes and helmets and things like that. But a lot of what we want to do is to try and improve your awareness of how you're sitting on your bike yourself, and how we can optimize that to get you to move through the air better by reducing both the CD and the A part of the CDA, and in turn getting a lower drag force by allowing you to move through the air better in a smaller shape. So hopefully you're looking forward to joining us on that journey, and we're looking forward to seeing an improvement with you over the winter and a faster season next year. Good luck, and we'll see you next week.